Okay, this is a quick video to go over your skills test 1 questions. The questions are presented in order, so I'll do question 1, then question 2, question 3, all the way through question 6. I'll put indices, index markers into the video so that when you see this, you can go to, if you go to the bottom along the red slider along the bottom where you can, go to a different time point in the video. If you just slide it along, you'll see where does question 3 start, where does question 5 start, and you can just go to the question that you want to review. Most of you did pretty well on question number 1. The question was convert 126 degrees to radians. What we're going to do here is multiply by 1, but we're going to do that in a very particular form. We're going to use the form a number divided by itself, and we're going to use the number 180 degrees over 180 degrees, except that the 180 degrees that we're going to put in the top, we're going to put that in radians, so we're going to call that pi. Recognizing that pi and 180 degrees are the same measurement, right? If I have a unit circle, this is 180 degrees. It's also pi. So this is the same measurement in 2 different forms. It's like using a different font. It's like using a different language to say the same word. So now that I have that little expression written down, I'm going to take, I'm going to reduce it, right? So let's do this. Let's cancel the degrees. And then I'm going to rewrite this as 126 pi over 180. Or you could think of it as 126 over 180 times pi. And then I have a fraction here that I can reduce. Technically, I said in class, and I'll stick with this, that if this was your answer, that would be adequate, right? That would earn you a check mark. That would earn you full credit. But it's best practice to reduce your fractions. So let's recognize that 126 and 180 are both divisible by 2. I get 63 here. If I divide 126 by 2, I get 63. If I divide 180 by 2, I get 90. So now I have the fraction 63 over 90 times pi. That would be an acceptable answer as well. I can also recognize that 3 goes into both of these. 3 goes into 63 21 times, 3 goes into 90 30 times. So another version of this fraction is 21 over 30 times pi. And lastly, I'll use blue again, 3 goes into both of these as well, 7/10. So my final answer, my final reduced answer is 7/10 pi or 7 pi over 10. And that's the answer to question number 1. For question number 2, you were asked to find the coordinates of the point on the unit circle at an angle of 5 pi over 3. So here's the unit circle, and this is 0 radians, this is pi over 2, this is pi, 3 pi over 2, and 2 pi. And we were looking for the angle 5 pi over 3. So here's 1 pi over 3, 2 pi over 3. Here's 3 pi over 3, right? That is 1 pi. Pi over 3, 3 pi over 3. 5 pi over 3 is 2 more pi over 3's beyond that. So I need to go all the way around to here. Let me redraw this unit circle. I'm looking at this angle right here. So because this is the unit circle, this is a radius of 1. This is a radius of 1, and this is a radius of 1. So the question is asking you, what are the coordinates of this point right here? And you can look that up on a unit circle chart, a unit circle diagram, or you can look it up in the table, the sine cosine table that gives you 0, pi over 6, pi over 4, pi over 3, and pi over 2. You can look the sine and the cosine up there. Remember that this is cosine theta. So in this case, it's cosine of 5 pi over, is it 3? Yes, 5 pi over 3, comma, sine of 5 pi over 3. And if you wrote down a unit circle on your note card, then you can literally just read those coordinates off the unit circle. And they would be 1/2, comma, negative root 3 over 2, right? I have a positive x coordinate and a negative y coordinate. So I have a positive and a negative, And the coordinates themselves come from the fact that this is the cosine of 5 pi over 3, and root 3 over 2, negative root 3 over 2 is the sine of 5 pi over 3. The other way you could have done this, and I don't think I really saw anybody try this, but it's certainly an option, is to use the table, and you have sine and cosine, and you have 0, pi over 6, pi over 4, pi over 3, pi over 2, 0, 1, 2, 3, and 4, and then we're going to take the square root, so I'm going to do it this way. Just recognize that's going to be 1. Take the square root, right? Actually, I don't need the square root for the 1, so I'm going to leave that there, and then I have the square root of 2 and the square root of 3. And then the cosine of that is backwards, so I have 0, 1 half, root 2 over 2, root 3 over 2, and 1. And I want the cosine and then the sine of, I want 5 pi over 3. My reference angle here is, this angle right here is pi over 3. That's how far it is from where I stopped back to the nearest x-axis. That's pi over 3. So I'm going to use these coordinates. That's going to give me the coordinates. Cosine of pi over 3 is a half. Sine of pi over 3 is root 3 over 2. But when I do it that way, I have to take into consideration that I'm in quadrant 4, so I'm going to have a positive x coordinate, which is positive, and then a negative y coordinate. So that makes my y coordinate, my sine there, negative. So whether you did it this way and got the coordinates that way, or whether you used the table and got the coordinates that way, either way is fine, but that's the correct answer for number 2. Number 3 says, the information we're given is that the cosine of t, so my angle is t here, is 4 over 5, and t is in quadrant 4. I'm going to use this notation for that, and I can explain it later. This basically just means is, where's my little hand, is an element of, or is in the set, or is in the space, quadrant 4. So I know, for example, from this information, that I'm playing in this playground down here, right? And I also know that the cosine of the angle that's in quadrant 4, the cosine is 4 over 5. So if that's my angle, this is technically my angle here, but I'm going to use the reference angle, the closest angle to the x-axis, to do the computations, right, to figure things out. So from this perspective, I have an angle, right, this angle right here, whose cosine is 4 over 5. So that means for that angle, the adjacent side, let's fix the reference triangle here. The cosine is adjacent over hypotenuse. So the adjacent side to this angle is right here, and that's going to be 4 over the hypotenuse, which is 5. Some of you drew that. Most of you drew that. And then most of you went on, well, many of you went on to get the correct final answer, but some of you didn't. Some of you kind of got lost in the weeds, I think, a little bit. From here, since what I want is the sine, I was asked to find the sine of t. Let me write that out here. The sine of t equals, and we're trying to figure that out. Well, sine is opposite over hypotenuse. I don't have the side opposite this triangle, or this angle, right? I just have the adjacent and the hypotenuse. But I can use Pythagorean theorem to find that third side. Let's call it b. And we know that a squared plus b squared equals c squared, but the hypotenuse has to be the c, right? So this has to be 5 squared. Since that's b, my a must be 4. So that's going to give me 16 plus b squared equals 25. Some algebra, sorry, I'm not subtracting 25, I'm subtracting 16. That gives me b squared equals 9, which means b, let me write it an extra step here. I'm going to take the square root of both sides. When I take the square root of both sides, I have to take plus or minus the square root. I'm the one choosing to take the square root. So I have to take into consideration the fact that it's either 3 or negative 3, that when you square it, gives you 9. So my answer here is b is either plus or minus 3. Okay, so the sine is going to be, that means that b is 3, right? The length of the side of this triangle is 3. So the sine of my angle is going to be opposite over hypotenuse, 3 over 5. But remember the playground that I'm in, right? I'm in quadrant 4. In quadrant 4, you can either think, well, look, x value here is positive, the y value is negative. And either keep that in mind. So I'm going to have negative 3 over 5, which is equal to negative the fraction 3/5. You can write your answer in either of these two forms. The other thing you could do, instead of thinking about the x-coordinate being positive and the y-coordinate being negative, is remember this mnemonic here. All students take calculus. Since what I'm looking for is the sine, and only cosine is positive here, that means sine must be negative. So my sine must be a negative number. That's the correct answer to number 3. In question 4, you were asked to find the exact value of the cosine of 5 pi over 4. Here's 5 pi over 4 again. Here's 4 pi over 4. 5 pi over 4 is one more copy of pi over 4 beyond that. So I'm going to come down here, right? Pi over 4s are the 45-degree angles between each, I'll do it in blue, between each axis, right? Between the axes. So this angle here is 5 pi over 4, and I want the cosine of that angle. So I'm going to use the reference angle to find it. This is a 90-degree angle. I know the cosine of, looking for my black pen here, I know the cosine of 1 pi over 4 by looking either at my table or at my unit circle. I know that's the square root of 2 over 2. But I'm looking for the cosine of 5 pi over 4. So I have to consider which quadrant I'm in and the fact that all students take calculus. I'm in quadrant 3. Only tangent is positive in quadrant 3. Sine is not positive there. Cosine is not positive there. Only tangent. I'm looking for a cosine. If it's not positive, it must be negative. So there's the correct answer to question number 4. All right, let's take a look at question number 5. I'm going to erase my table there, or my graph. Question number 5. We are told that a right triangle has one side, one angle. I think we have a side as well, but I'm going to do these in the same order that the information is given to me. We have an angle of pi over 3, and we're told that the hypotenuse is 20. We're also told it's a right triangle, so we know that we have one right angle as well. This is the sort of shorthand notation for angle. Here's a right triangle. You can draw it in any orientation, but I'm going to draw it like this. Let's see. Find the unknown sides and angle. I was given that the hypotenuse was 20. Sorry, I've got the wrong pen there. Hypotenuse is 20. And I'm told that one angle is pi over 3. So I'll make this one pi over 3. And I'm asked then to find the other angle and the other sides. Okay? I only know one side, so I can't use Pythagoras, or at least I can't use it yet to find the missing side, right? I need two sides of a right triangle to find the third side using Pythagoras. What I can do though is I can recognize that this is a 90-degree angle. This is the equivalent of a 60-degree angle. Therefore, this has to be a 30-degree angle. Okay? I'm going to put my answers in blue. But I'm in radians here, right? This is pi over 3, not degrees. So this should be pi over 6. A lot of you wrote 30 degrees, which is equivalent, but the problem is given in radians. So it's fine to convert this to degrees, do the work, and then convert back to radians, but don't forget to do that last step. If the problem is given in degrees, then you can give your answer in degrees. Let me just grab a highlighter real quick. This is the correct answer for this part of question number 5. So we know all 3 angles now in our triangle. We only know one side, but we also know that, for example, the sine of pi over 6 is a half. Okay, we know that fact from a table or a chart or a unit circle or various different ways we could we could have that information handy, right? The sine of pi over 6 is a half, but the sine of any angle is its opposite over the hypotenuse. Let's call this A. So the sine of pi over 6 in this case is A over 20. That means, let me back up a little bit. The sine of pi over 6 we know is a half, but the sine of pi over 6 in this case is A over 20. So because those two things have to be equal, I can create this little proportion here. I can now kind of ignore this piece right here because the sine of pi over 6 and 1/2 are equal, they're equivalent. I can replace that with a half and then say, oh, but the sine of this pi over 6 is A over 20. So I have this little equation here, and I can use cross multiplication or a variety of different techniques to solve it. A here has to be 10. So now I know that A is 10. And now that I have two sides, I can figure out what the third side is. I have two options here. One is that I can say either the cosine of pi over 6 is root 3 over 2, but that in this case, the cosine of my pi over 6 angle is this adjacent side. I'm going to call that B equals is adjacent over hypotenuse, so I'm going to say that that has to be equal to B over 20, and I'm going to solve that proportion. Okay, so I'm going to leave that because that's one method. The other method is that now that you have two sides of a right triangle, you can use the Pythagorean theorem. So another way to do this would be to say that A squared plus B squared equals C squared, and I know what A is. It's a 2. I don't know what B is, but I do know what C is. That's going to give me 100 plus B squared equals 400. I wrote a degrees there instead of another 0. That's really weird. Why my brain did that. Oh, I wrote it instead of a squared. Okay. I'm going to take this up here because I'm out of room. If I subtract 100 from both sides, I get B squared equals 300. So now I want to take the square root of both sides. That's like saying, well, that's B clearly, but that's like saying 100 times 3, which is 10 root 3. Okay, so the side B here is 10 square root of 3. And that's the answer to question number 5. Note that there are 3 parts to the answer here. We have the 2 missing sides and the missing angle. Okay, so there's 3 parts to this one. All right, for question number 6, we are told that, we're asked to evaluate the expression, the cosine of the sine inverse of 3 over 5. All right, so I want to take the cosine of an angle. The angle in this case is all of this. So I need to figure out what that has as a value so that I can find its cosine, right? We have a couple of different ways of doing this. If you have a 3/5 as as a y coordinate on your unit circle, then you can say that the angle associated with this here is the angle that has a sine of 3/5, right? And then you can just figure out what that angle is, stick it in there, and then take its cosine. The problem is there isn't an angle whose sine is 3/5. There is, but it's not on your unit circle. Okay, it's not one of our friendly familiar angles. It's just some random angle. The angle whose sine is 3/5 is not one of our common angles. So we need to do this a different way. What I'm going to do is, let's see, do I want to do it as a unit circle or do I think I'm just going to use a triangle. No, I think I'm going to use a unit circle because I have to take the sine SIGN into account. Okay, so here's my unit circle. Well, that's terrible. I'll try again. It's not great, but it'll do, all right? And it's a unit circle specifically, so the radius is 1. Anytime I draw a line anywhere from the center of the circle out to the edge of the circle, that line is a radius of the circle, and in this case, that's 1. It's a unit circle. What I'm told here is that there's an angle whose sine is 3/5. That means there's an opposite over hypotenuse relationship that's 3 over 5. So that could happen here. I'm going to draw my reference triangle. That would make this side 3 and the hypotenuse 5. But I just got through telling you that this had to be 1, right? So there are a couple of different ways we could approach this. One is we can say, we'll just divide everything through by 5. The other way is to say, well, remember what we talked about in the previous problem, is that if the sine of some angle, I'm just going to call it theta for now, is equal to 3 over 5, but I know that that has to be equal to something over 1, and I can solve this for, let's see, 5x equals 3. X has to equal 3/5, right? Well, that's pretty much what I started with, so I'm really not much better off with that information. What I can do, though, is I can say, again, there are a couple of different approaches. If I imagine that this is just a triangle floating in space, it's not part of the unit circle, then I can say, well, I've got a side of 3, a hypotenuse of 5. If I use the Pythagorean theorem, I'll quickly recognize that this other side is 4. And then I can take the cosine. I've now found the angle. I haven't actually found the value of the angle, but I've used the information I know about the angle to find the third side, and so I can take the cosine of that same angle even without knowing the value of that angle. The cosine of my angle, sorry, different color pen here, in this case, is equal to the adjacent over the hypotenuse. Now, there's one more thing to take into consideration here, and that is that the sine inverse, right? Hang on a second. Where is my pointer? I can play with sine inverse anywhere in either this quadrant or this quadrant. Let me highlight those. Do it in green. Right? I can do that there or there. Sine inverse. The sine inverse playground starts here, negative pi over 2, and goes to pi over 2. Right? So I'm allowed to play this game in this playground. The other thing to take into consideration, however, is that all students take calculus. And so this is a positive 3/5. Where is sine positive? It's positive here and it's positive here. So I'm going to color these two quadrants in. So I have to be in one of these two quadrants and I have to be in one of these two quadrants at the same time. So it has to be where they overlap, right? Therefore, I know that my 3 is positive. I also know that my 4 is positive. All right, so this is my final answer to question number 6. I'd like to show you just for fun, one other way you could think about this. I said that this was a unit circle and then I kind of ignored the fact that it was a unit circle. Let's go back to the assumption that it is a unit circle. I'm having a hard time drawing my circles today. It is a unit circle, but I'm going to go ahead and draw my 5 and my 3 here. If this is a unit circle, it can't have a radius of 5. It has to have a radius of 1. So I'm going to divide that by 5, but that means I have to divide everything by 5. So this side's going to be a over 5, right? If the sine, let me make an observation here. This is now equal to 1. If the sine inverse of 3/5 means that the sine of our angle equals 3/5, that's opposite over adjacent, which is 3/5 over 1, which is 3/5, right? What's the cosine? Well, you could use the Pythagorean theorem here, or you could use it like we did here before and then divide by 5. I could divide the 4 by 5 as well. So in fact, my A here is going to be 4. Get the right pen. And then when I look for the cosine of this angle, I want the adjacent over the hypotenuse. So that's 4/5 over 1. Okay, so I end up with the same answer. I just kind of took a slightly different approach.